In section 5.2, we look at the integers and order of operations. So in section 5.1, we applied some ideas of number theory to the set of natural or counting numbers. That was 1, 2, 3, and so on. When we combine the number 0 with the natural numbers, we obtain a new set called the whole numbers. So it's the same exact set, we just add 0 to it. The whole numbers do not allow us to describe certain everyday situations like overdrawing or bank accounts. This would lead to a negative number. The set consisting of the natural numbers, 0, and the negatives of the natural numbers is called the set of integers. So that's like -4, -3, -2, -1, 0, 1, 2, 3, and 4, and it keeps going in both directions. And those positive integers are just the counting numbers of the natural numbers that we learned in the first section. The number line is a graph we use to visualize the set of integers as well as the sets of other numbers. The number line extends infinitely in both directions, shown by the arrows on the left and the right. 0 separates the positive numbers from the negative on the number line. 0 is neither positive or negative. For every positive integer on a number line, there is a corresponding negative integer on the opposite side of 0. So let's go ahead and graph -3, 4, and 0. So -3, we're just going to put a dot on -3. Let's plot 4. And let's plot 0. So you just find the point and you put a dot on it. We will use the following symbols for comparing two integers. The arrow opening to the right means is less than, and the arrow pointing to the left is greater than. On a number line, the integers increase from left to right. The lesser of the two integers is the one farther to the left on the number line, and the greater of the two integers is the one farther to the right on a number line. So looking at the graph, we have -4 and -1 graphed below. Since -4 is to the left of -1, this means that -4 is less than -1. Since -1 is to the right of -4, this means that -1 is greater than -4. These symbols are called inequality symbols. These symbols always point to the lesser of the two real numbers when the inequality statement is true. So we need to insert the right symbol. Between -4 and 3, well, since 3 is positive and 4 is negative, that means we will always have 3 greater than -4. So -4 is less than 3. Between -1 and -5, -5 is to the left of -1. And so that means that -1 is greater than -5. Between -5 and -2, -5 is to the left of -2, which means it's less than. And 0 is to the right of -3, which means 0 is greater than -3. Now these symbols may be combined with an equal sign as shown in the following table. A is less than or equal to B. So 2 is less than or equal to 9, or 9 is less than or equal to 9 would both be true statements. Or we can do it the opposite way. B is greater than or equal to A. So 9 is greater than or equal to 2, and 2 is greater than or equal to 2 would both be true statements. The absolute value describes the distance from 0 on a number line. If a represents an integer, the symbol, the absolute value of a, represents its absolute value. The absolute value of an integer a, denoted by vertical bars with an a in between, is the distance from 0 to a on the number line. Because absolute value describes a distance, it is never negative. So what it does is it turns the inside to a positive number. If it's negative, it turns positive. If it's positive, it's going to stay exactly the same, and 0 will always be 0. So to find the absolute value of -3, we just take the inside and make it positive, and so we get 3. The absolute value of 5, because it's already positive, is going to stay exactly the same, and that's just 5. And the absolute value of 0 is just going to be 0. The absolute value of a positive integer, or 0, is just the number itself, and the absolute value of a negative number is just the number without the negative sign. The absolute value of any integer other than 0 is always positive, and that's just because 0 doesn't have a positive or negative sign. The result of adding 2 or more numbers is called the sum of the numbers. You can think of gains and losses of money to find sums. For example, to find 17 plus -13, think of a gain of $17 followed by a loss of $13. There is an overall gain of $4. In the same way, to find -17 plus 13, think of a loss of $17 followed by a gain of 13, and there is an overall loss of $4. So the rules for addition of integers: if they have the same sign, we just add their absolute values, and then the sign is going to be the same as the sign of the two numbers. And if they have different signs, you want to subtract the smaller absolute value from the larger absolute value, and then the sign will be the same as the sign of the number with the larger absolute value. So we've got -11 plus -15. So they're both negative, they have the same sign, and so what we want to do is we are going to take the absolute value of 11 plus the absolute value of 15. And when I add those together, I get 26, but my original numbers were both negative, so that means that this is -26. What about -13 plus 4? Well, we want to subtract the smaller absolute value from the larger one. So we're going to subtract the absolute value of 4 minus the absolute value of 13. Well, 13 minus 4 gives me 9. And since 13 is the greater absolute value and it was negative originally, that means that this is going to be -9. Same thing with 13 plus -6. We want to subtract the smaller from the larger. So the absolute value of 13 minus the absolute value of 6, which is going to give me 7. And since 13 has the greater positive absolute value, and it was positive, that means we are going to keep this as just +7. Additive inverses have the same absolute value, but they just lie on opposite sides of 0 on the number line. So 18 and -18 would be an example. If I were to add them together, I would get 0. When we talk about subtraction of integers, let's suppose that a computer that normally sells for $1,500 has a price reduction of $600. The computer's reduced price, $900, can be expressed in two ways. We could do 1,500 minus 600, which is 900, or we can use the additive inverse, 1,500 plus -600, and we will still get 900. So for all integers a and b, a minus b can be written as a plus -b. And so that's going to give us the difference. So let's go ahead and subtract. So we're going to rewrite these. Now, one thing to keep in mind is that if I have two negatives, this is going to end up giving me two positives. And so 17 plus 11 is just going to give me 28. Same thing goes with the second one. I have two negatives in the middle, so we really end up with negative 18 plus 5. Now we would want to make sure that we take the smaller absolute value from the larger. So the absolute value of 18 minus the absolute value of 5 is 13. But because 18 is the bigger absolute value and it was negative to begin with, we get negative 13 as our answer. And negative 18 minus 5, we can always rewrite this as negative 18 plus negative 5. Well, both of these are negative, so we just need to add them together. The absolute value of 18 plus the absolute value of 5 gives me 23. And since they're both negative, we end up with negative 23. Multiplication of integers. The result of multiplying two or more numbers is called the product of the numbers. You can think of multiplication as repeated addition or subtraction that starts at 0. So the rules for multiplication of integers: the product of two integers with different signs is found by multiplying their absolute values, and the product is negative. The product of two integers with the same sign is found by multiplying their absolute values, and their product is positive. The product of 0 and any integer is 0. If no number is 0, a product with an odd number of negative factors is found by multiplying the absolute values, and the product is negative. And if no number is 0, a product of even number of negative factors is found by multiplying absolute values, and their product is positive. So if we have the same sign, it's going to be positive. If we have two different signs, it's going to be negative. Anything that is multiplied with 0 is 0. If I have an odd number of negative factors, so 3, 5, 7, then we get a negative number. And if I have an even number of negative factors, like 2, 4, 6, 8, I'll get a positive number. So 7 times negative 5, I have one positive, one negative, which means this is going to be negative. And 7 times 5 is 35. Negative 6 times negative 11, they're both negative, so this is going to be positive. And 6 times 11 is 66. Negative 17 times 0 is going to be 0. Anything multiplied with 0 gives me 0. For part D, we have 3 negative factors, which means it's odd. So we're going to get a negative number. And then we just want to multiply 2 times 3, which is 6. And 6 times 5 is 30. So we end up with negative 30. And negative 2 times 3 times negative 5. We have 2 negative factors, which is an even number, so that's going to give me a positive, and positive times positive is positive. So let's go ahead and just multiply the first two. Negative 2 times 3 gives me negative 6 times negative 5, and that's going to give me positive 30. Now, exponential notation is what we use to simplify things. So because exponents indicate repeated multiplication, rules for multiplying integers can be used to evaluate exponential expressions. So -6 squared, because the negative and the 6 are inside the parentheses, that means we're going to have -6 times -6, because it's twice, it's squared. Two negatives make a positive, and 6 times 6 gives me 36. Now for the second part, the negative is not being squared, only the 6 is. So that's like having a negative out front, and then we have 6 times 6. Well, 6 times 6 is 36, and we still have the negative up front. -5 cubed means that I have -5 3 times. Because there is an odd number of negative integers, that means that we are going to end up with a negative number. And 5 times 5 times 5 is 125. -2 to the 4th is just -2 4 times. And because there is an even number of negative numbers, that's going to give me a positive number. And 2 times 2 times 2 times 2 is 16. So we end up with positive 16. The result of dividing the integer a by a non-zero integer b is called the quotient of the numbers. A relationship exists between multiplication and division. Because of the relationship between these two, the rules for obtaining the sign of the quotient are the exact same as those for obtaining the sign of a product. So the quotient of two integers with different signs is going to give you a negative number. The quotient of two integers with the same sign will give you a positive number. 0 divided by any non-zero integer is 0, and division by 0 is undefined. So 80 divided by -4, 1 is positive and 1 is negative, which means this is going to be negative. And 80 divided by 4 is 20. -15 divided by 5, we have 1 positive, 1 negative, which means this is negative, and 15 over 5 is 3. So we end up with -3. We have 27 over 9. These are both positive, so we're going to get a positive number. And 27 divided by 9 is 3. -45 divided by -3, we have two negative numbers, which means this is going to be positive, and 45 divided by 3 is 15. This is where people get confused. Is 0 on top okay, or 0 on the bottom okay? So a way to remember this is okay, because the 0 is on top. If it's okay, the answer will always be 0. Now if the 0 is on the bottom, that's NO, which is not okay, and we say that this is undefined. And the last thing we want to look at is order of operations. So this just ensures that there is only one correct answer. So the first thing you're going to hit is the parentheses. This is any grouping symbols, whether it's square brackets or curly braces, and you want to make sure that you simplify those first. Then you're going to hit the exponents. So anything with an exponent attached, you want to simplify next. We do multiplication and division on the same step, and you do them from left to right. The same thing goes for addition and subtraction. They're on the same step, but they are done from left to right. So let's go ahead and simplify. We've got 6 squared minus 24 divided by 2 squared times 3 plus 1. So the first thing would be parentheses, if I'm looking at PEMDAS. Well, in this case, we don't have any grouping symbols, so we don't need to worry about the P part. The next is going to be the exponents. So we want to simplify exponents. So 6 squared and 2 squared need to be simplified first. So 6 squared gives me 36 minus 24 divided by 2 squared, which is 4, times 3 plus 1. The next is multiplication and division, and these get done on the same step. We just do them from left to right. So the first thing you want to do is you want to do the 24 divided by 4. So we have 36, and negative 24 divided by 4 is negative 6 times 3 plus 1. And we want to make sure that we get the negative 6 times 3. So negative 6 times 3 is negative 18 plus 1. And that takes care of all the multiplication and division. The next thing is to do addition and subtraction. And we do this from left to right as well. So we're going to do 36 minus 18 first, which is 18. Plus 1, which is 19. Let's try example number 10. We've got negative 6 squared minus 5 minus 7 squared times negative 3. So the first thing is the parentheses. And the parentheses in this case means if we have 2 or more terms. So the 5 minus 7. The other 2 parentheses are just grouping the negative and the number together to indicate multiplication. So we don't have to fix those. So we have negative 6 squared minus 5 minus 7 is negative 2. So that takes care of our grouping symbols. The next thing is exponents. So we need to simplify negative 6 squared and negative 2 squared. Negative 6 squared is 36, and negative 2 squared is 4. And that takes care of our exponents. The next thing is multiplication and division, which we only have multiplication involved here. We've got negative 4 times negative 3, and that's going to give me 12. And then the last step is to do addition and subtraction from left to right. And we really only have one thing to do, and that gives me 48.